We're not going to do any solving. It says Scott drives a truck for a soft drink company. His truck is filled with 15-ounce cans and 70-ounce bottles. Let C be the number of 15-ounce cans the truck is carrying. Let B be the number of 70-ounce bottles. The truck must be carrying less than 4,000 pounds or 64,000 ounces. Using the values and variables given, write an inequality that describes what's going on. So I have 15-ounce cans, so if I take 15 times the number of cans, I'm going to have the number of ounces that I have cans. I'm also carrying bottles. Each of my bottles is 70 ounces, so if I take 70 times the number of bottles, I have the number of ounces of bottles that I'm carrying. The truck must be carrying less than. And which one of those two numbers there should I be using?
4,000.
Go back and look at the question. What units are you using on the first part of the question? Ounces. So if I'm using ounces up there, I have to use ounces in my problem, right? So instead of using the 4,000, I'm going to use the 64,000. So they're not going to have you solve it, they're just going to have you translate it, and that's what we're going to have. Number 11, in a race, car 1 went an average of 150 miles an hour for X hours before dropping out. Car number 2 went an average of 170 miles an hour for Y hours before dropping out. The distance car 1 traveled was at least that of car 2. Using the values and variables given, write an inequality describing the situation. So, for the distance for car 1, how would I write that down? What's it tell me about car 1?
15 over your X. Or 150.
150. Now if I'm going 150 miles an hour for X hours, how do I find the distance? You multiply them. So 150 times X would just be 150X. That's going to be the distance the first car went. Rate times time equals distance. The second car went an average of 170 miles per hour for Y hours. How am I going to show his distance? Multiply again. 170Y. Now, we have to figure out, because we've done this before, what symbol do I use for at least? Car 1 went at least that of car 2. Greater than or equal to, exactly. There's my expression then. Right, you had that little table to add at most, at least, not, not less than, whatever all those weird sayings were. And the last one. A landscaper is planting a tree that is now 48 centimeters tall. The tree will grow 4 centimeters per month for X months. The tree will grow to be less than Y centimeters tall. Write an inequality showing this relationship. So, my tree started out at 48 centimeters. It is now going to grow. So if it's going to grow, what am I going to do? Add to the tree. It's going to grow 4 centimeters per month for X months. 4X, exactly. The tree will be less than Y centimeters tall. So my inequality, 48 plus 4X, is less than Y. Those ones will probably take you a little bit of practice. Just write down lots of examples. So if you get to it on the assessment, you've got some things to look at. That is the end of chapter 3. So if you look at your pie chart,